is Ria Charlie, pursuing MS in Data Science from Cardiff Metropolitan University. Today I'm here to show you the project in data analysis using Google Colab and connecting it to GitHub with a Streamlight app using paging air quality dataset from UCI machine learning repository. It actually contains 12 datasets in which I have selected few of the datasets for my project. Moving on to the first step, initially we will import the dataset into Google Colab. Before that, we need to import the necessary libraries like pandas and read the CSV file. I have used Streamlit library for GUI application. For data manipulation, I have used pandas, and for data visualization, I have used Seaborn. For model evaluation and training, scikit learn modules were used. Once done, we will then merge the datasets as a single file and make it as a single data frame. Once this is done, we are ready for the analysis. Next step is to gain insights about our data and understanding the outliers like missing data, how many rows and columns, some statistic summary. If we find any missing values, ideally we will handle them by imputation or by discarding the rows and columns. Another issue is data misalignment, which means inconsistent data types, which we handle manually for smooth process. Once this is done, we will clean the data to remove inconsistencies and errors in the data, and we will use the imputation techniques to handle the missing information. We will now begin with the data analysis of a Beijing data. First step is to do EDA, exploratory data analysis, which will help us to understand the data patterns using distribution and scatter plots. Then we will choose the machine learning models to predict the outcomes, and then finally we have rational for method selection. For EDA, I have used univariate, bivariate, correlation matrix, and many more. I've shown here two. The first bar plot is to plot the distribution on frequency and PM 2.5. The other is plotted between PM 2.5 and temperature. After EDA, we will now move on to the machine learning techniques. First is linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variable, which it has it had two outcomes: mean squared error had 1027.006, which representing the average square difference between actual and predicted values, whereas the R square is 0.8396, which means approximately 83% of the variance in the dependent variable is explained by the model. Next is gradient boosting. Again, here we have mean squared error and R square, where mean squared error is 987.03, which is significantly lower than that of the other models, and R square value is 0.9331, which indicates that approximately 93% of the variance in the target variable is explained by the model, suggesting a strong fit. After performing the machine learning techniques, we have different outcomes for which we have to choose the best. Hence, I've chose a bar plot to select one, which I have chose random forest as it has the best accuracy. I have developed a GUI app using Streamlit, where there are three pages showing data overview, EDA, and model protection. Data set overview shows a few rows of the data in, and exploratory data analysis has um, ranging from 2013 to 2017. uh, I've shown the bars using a slider, and based on and on the model and protection, it will show the predictive modeling process for the data set. Here is the Streamlit GUI app, where this is the exploratory data analysis and the code for the Streamlit app. Here in exploratory data analysis, this is a slider which we can adjust uh, uh, the year range, and we can see the distribution of PM2.5, and this shows the data between the year range which we have selected from the slider. After doing the whole project, there are few key findings and recommendations. The first key finding is superior performance of the random forest, uh, which outperforms other models with an R squared value of 0.9331. And second is the impact of data processing and feature engineering, such as filling the missing values and significantly improving the performance of the model. The recommendations are hyperparameter optimization of the random forest model using techniques like grid search to further enhance predictive accuracy, and second recommendation is incorporating additional features like meteorological data and time-based variables. Third is the real-time data integration for dynamic predictions of air quality forecasting. While doing this project, I observed the few data quality issues and model constraints. The first is the missing data, which led to biased results and which was handled using imputations. Noisy data, disordered data can cause incorrect model learning and predictions, um, overfitting, and limited model interpretability. It is very important to show our work in public, and to do this, I have used the GitHub. I have collaborated the Google Colab with GitHub in local system using using GIT. Yeah, and that's it. That's how I've done my project. Um, I've also uploaded the Google Colab file. In case of any issues, you can also check over that. Thank you.